All right, sorry about my voice coming down with a cold, so it's about 4 octaves lower than it should be. Today we're going to radians and degrees. This is basically two different languages. We're speaking English, speaking German, or however you want to say it. Degrees are pretty familiar with. We've dealt with them a lot in geometry, as far as how many degrees are in a triangle, all that stuff. And so we're going to use some of that prior knowledge as far as degrees in an angle, degrees in circles, all that stuff. As far as radians go, I'll explain what that is here momentarily. The first thing is we need to talk about just terminal and what that means. For any given angle in a circle, we have a terminal side, which is just another radius. Uh, but when we're talking about that, it's talking about the other side that forms the angle. And so when we're trying to find positive and negative coterminals, coterminal angles, I should say, what we're going to do is just add 360 and subtract 360 to that uh, degree. And so for a positive coterminal, we'll add, I think it's obvious, add positive, all that stuff. And then for negative, we're going to subtract. Subtract and negative kind of go together as well. Coterminal is just, co, with, same, all that stuff. Just which angles share this same terminal side. So if I were to add 360 to this, I would get 407. If I subtract 360 from this, I would get negative 313. And so positive and negative when we're dealing with angles isn't like bad, good, anything like that. It's just talking about which way we're going. And so I'll show you an example here in a little bit of positive, negative, what all that means. If our angles are in radians, which you'll see what I mean here in a moment, then we're going to add 2 pi or a multiple 2 pi. And the same thing for 360. We can add 720, blah, blah, blah. And then to find a negative coterminal, if it's in radians, we're going to subtract or add 2 pi. Um, what a radian is basically if I take myself and I'm right here and I travel to there, this distance along that edge, when that matches what the radius is, that's called a radian. And there's 6.28, that's a rounded number. If we took pi, which remember pi is 3.14, and we multiply by 2, there's 6.28. And so what we often refer to in radians is that there's 2 pi, just like there are 360 degrees. And so if I wanted to figure out how much was in half a circle, that's 180 degrees, or just pi. The last thing I want to talk about here is talk about how to convert from radians to degrees and degrees to radians. The first thing is converting degrees to radians. So we got this angle, 90 degrees, right angle, all that stuff. To convert degrees to radians, we're going to multiply by pi over 180. So that's what I have written right over here. If we're going the other way, we're going to multiply by the reciprocal 180 over pi. So then we just follow our steps. This is 90 over 1, so then I multiply straight across. So 90 times pi, 180 times 1. Or we could reduce just a little bit before we get started. So I cross out the zeros. So now I'm just left with this 9 pi over 18, which leaves me finally with pi over 2. Same thing here. I got 120 over 1, just 120 degrees. So 120 times pi over 1 times 180. We can reduce again, 0 and that 0. So I got 12 over 18, which reduces down to 2/3 pi. And then we're going the other way. So we're taking pi over 2, which we just said was 90 degrees up here, so that should be kind of a review, hopefully. Or 5/4 pi, or 5 pi over 4, however you want to say it. And we're going to degrees. So multiply straight across yet again. Now this time my pi's cancel out, and that's important because I don't want radians, I want degrees. Radians deal with pi, degrees don't. So that's why my pi's cancel out. Multiply straight across, divide, and we know pi over 2 is 90 degrees. And same thing here, if I got 5 pi over 4, multiply straight across, the pi's cancel out, I don't have any more pi's anymore, I have 225 degrees. Multiply by 180 over pi when I'm going radians to degrees, multiply by pi over 80 when I'm going degrees to radians. The last thing I want to talk about is the unit circle. Today in class, had all the kids fill this out. I think I need to zoom in just a little bit. Maybe not. Sorry, bear with me. Is this any better? It's a little bit. Anyway, I don't know what happened here. Sorry about that. This is still quadrant 1. The unit circle is pretty pivotal as far as what we're doing here. You know what? I'm just going to redo this. Sorry about that. Okay, here we go. The first thing is this ordered pair is 1 comma 0. That's just 1 unit away. So this would be 0, 1, this is -1, 0, and then this down here is, my bad. Oh my gosh, sorry, been a day. 0, -1. Next thing is that since this is the x-axis and this is the y-axis, that's how we knew all that. Next thing is the quadrants. So that's 1, 2, 3, 4. Makes a C, right? Makes a C as far as counterclockwise. Next thing is that this line right here, this ordered pair, represents two different angles. Represents 0 and represents 360 degrees, which also represents 0 to 2 pi in radians. If we start at 0 here and I went over here, this would be pi, and that's 180 degrees. What's halfway in between there? 90 and pi over 2. So down here, this would be 3 pi over 2. Sorry, I was trying to figure out where to write that. 3 pi over 2, or 270 degrees. The last thing we're going to talk about is all the angles in between here. If this is divided up, this is going to be 30 degrees. This will be your 60 degrees. And nope, that's a lie. Wow. This is 45 degrees, and this one is 60 degrees. So there's a little pattern every single time, as long as I get it right. So this one's 120 degrees, this one's 135 degrees, and this one's 150 degrees. As you can see there, we're just jumping up by 15 in between here every time. Jumps up by 30. So this one's 210 degrees, 225, and 240. And then last one is 300, 315, 330. We will eventually get to everything else as far as the ordered pairs and the radians. This is a slow process. We'll get through this. I'm not expecting you to know this overnight, but eventually the goal is for you to get to be very familiar with all this. The last thing I'm going to talk about is down here at the bottom of what I wrote. Anytime we have a positive angle, that means we're going counterclockwise. So we're going from our right to our left this way. Anytime we have a negative angle, we're going clockwise. So we're starting here and going down. So a negative angle doesn't necessarily mean a bad thing. Positive isn't good. It just means as far as our orientation, which way we're going. So positive this way, negative this way. That's all I got. Quick day today. Have a good day.